Good day. I am JM, an ID 120 student taking up civil engineering, and I'll be teaching ENGMEC3 quiz number 1. Okay, so to start off, ENGMEC3, or also with the course title, which is Mechanics of Deformable Bodies, it deals with the study of resulting stresses and strains developed in bodies as a result of external influences or actions. This course aims to answer questions such as how much is the deformation that happens to a body when you apply a certain external force. Next off, it also answers questions to how much force can a body withstand without it failing. So you have to know that certain bodies, for example, or uh, concrete or steel, they tend to break when you subject it to excessive force. And lastly, it also deals with finding out the best shape of a body. So, by the best shape of a body, this implies that we can mold different materials into different shapes. For example, we can have steel that would be just cylindrical or like a pipe, so it's cylindrical in nature. Or we can also have a flanged steel. So when you have a flanged steel, you will know that it has a top and bottom flange, or you can also have it as a T-steel. So in that case, it would only have a top flange and not a bottom flange. And there are different bodies or different shapes of a body that are being studied nowadays in order to ensure that we can optimize our materials and ensure that it can still withstand a considerable amount of force. So in ENGMEC3 quiz number 1, we would first determine how deformations are caused by excessive forces, as well as how the effect of a change in temperature can affect our bodies. So moving on to our first example, we have here a wooden block that is subjected to a compressive force of 2 kilonewtons. We have to determine the average normal and average shear stress developed in the wood fibers that are oriented along section A-A at an incline of 30 degrees with the axis of the block. So to further explain what this problem is trying to solve, so we have here section A-A, which is here. So let me just encircle it. Then we also have our angle. The angle refers to our incline and how much the section is inclined with respect to the bottom axis, bottom horizontal axis. So we also know that a 2 kilonewton compressive force is applied at both sides, and it's also possible to determine that if we cut our plane at the A-A section, we will get a different free body diagram. And that is what we will be doing because we want to determine only the normal and shear stress that is developed at that section. So first, let me draw the cut shape or the cut free body diagram of the block considering section A-A. So this is section A-A or the cross section of the block after it is cut at the section A-A. We know that a 2 kilonewton force is applied here. And we know that when we cut the plane, shear would develop on that section parallel to the cut. So let's label our shear V, and the normal force is applied perpendicular to the section. So this is N. So how do we get the two values using our given compressive force? What we can do is divide our 2 kilonewton into components which is parallel to the shear force and the normal force. So how do we do that? We know that this is 30 degrees. So we know that the shear and the normal force are inclined 30 degrees above the horizontal axis. So what we can do is also create an inclined plane or an inclined axis. Let's say this one. So this is perpendicular, meaning the total angle here is 90 degrees. But it is also parallel to this two. So let me repeat, this axis is parallel to the normal and shear axis. So we have here, let me remove the 2 kilonewtons first and transfer it, let's say here. So we have here an incline where this is also 30 degrees, and we know that this is 60 degrees because these are perpendicular to one another. And if we want to transfer the compressive force, what we do is we apply our trigonometric properties. So we can use cosine for both or sine for the other if we want to consider only one angle. So considering that we only have 30 degrees as our given, let's first do that. So for this one, we will develop a force along the shear, which would be 2 kilonewtons cosine 30 degrees. Why is it cosine 30 degrees? We use cosine because it is directed towards the angle. If it's towards the angle, we use cosine. If it goes away from the angle, we use sine. So given this information, the bottom force component, which would be parallel to the normal force, would be transformed into 2 kilonewtons times sine 30 degrees. So there you have it. And now, if you want to focus on the forces that are applied on the body itself, let me draw it here at the bottom. We will get here a 2 kilonewton force multiplied by sine 30 degrees. Here, a 2 kilonewton force multiplied by cosine 30 degrees. We will get here a missing normal force, and we will get here a missing shear force. So we get this by just taking our summation of forces along a specific axis. So usually our axis is like this. This is the XY axis. So this is positive X. This is positive Y. But in this case, it would be better if we created a different axis wherein it's like this. And like this. So let's label this positive N axis and this as positive V axis. So let's remember the conventions and take our summation of forces. So the summation of forces along X axis must always be equal to 0. Therefore, we can say that so let's start off with the summation of forces along the V axis. So this is where the V or the shear happens. So the summation of V must equal to 0, or the summation of forces along the shear axis. Therefore, we have positive V since it's directed towards the positive V direction, minus 2 kilonewtons times cosine 30. Because as you can see, if you focus on the body itself, so let me just show you how the thought process goes. So as you can see, if this is the body, the 2 kilonewtons is compressing the body, and it's negative because it goes against the direction of the positive V. So there's that. 2 cosine 30 equals 0. Using a calculator, V is equal to 2 cosine 30 degrees, which is equal to 1.73 kilonewtons. On the other hand, the summation of your forces along the normal axis is also equal to 0. This time, our normal force is acting away from the positive n. Therefore, we have a negative n here, and a positive 2 kilonewton sine 30 degrees is applied because it is headed towards the positive n direction. Plus 2 sine 30 degrees equals 0. Using a calculator or using your unit circle, you know that sine 30 is equal to 1. So, to 1/2. So, 1/2 times 2 is just 1 kilonewtons. Therefore, our final answer is, let me just rewrite, the normal force applied is 1 kilonewtons and the shear is equal to 1.73 kilonewtons along section A-A. That is your final answer. Thank you so much for watching. You may also avail syntax tutorials by scanning the QR code flashed on your screens. Once again, this is JM from Syntax, paving your way to excellence.